Let's talk about complex fractions. Complex fractions are fractions that have fractions inside of them. So little fractions inside big fractions. We look at this first example here. We have 4 divided by 3/4 minus 3/2, and we have to simplify this. When we simplify these, we don't want to have fractions and fractions. At the most, we want to have one fraction in this problem. So the key to doing this is to multiply every term by the LCD of all the baby fractions. Remember, LCD means the least common denominator. And by baby fractions, I mean these little guys, the ones that are inside of the big fraction. Now, if we look at the 3/4 and the 3/2, the least common denominator of those two would be 4. So what I'm going to do is I'm going to multiply every term in this entire complex fraction by 4. That means that I'm going to multiply the 4 up here by 4. I'm going to multiply the 3/2 down here by 4. And the 3/4 over here by 4. Now when we multiply by a 4, if it helps you, you can think of this as 3 separate problems. In blue, we have the problem 4 times 4, which as you know is just 16. In green, we have the problem 4 times 3/4, which gives you 12 in the numerator, and in the denominator, we have a 4. Now, if you want to make the 4 into a fraction, you can, but notice that 1 times 4 in the denominator is still 4, and 12/4 is equal to 3. And finally, in purple, I have 4 times -3/2. And I call this -3/2 because there's a minus sign here. So when I multiply these, I get -12 in the numerator and 2 in the denominator, which simplifies to -6. Now if I take all those values and put them back into the problem where they were, I get 16 divided by 3 minus 6. And 16 divided by 3 minus 6 can be simplified to give us 16 divided by -3, which you can leave just like that. You don't have to put in your calculator to get a decimal. You can put the negative sign up top with the 16. You can put the negative sign right in the middle in front of the fraction bar. But any of these 3 answers is perfectly fine for the simplified version of your complex fraction. So we took a big fraction with lots of little fractions inside of it and made it into one simpler fraction. Well, let's look at another one. Here we need to find the LCD of all the little fractions. We have a 4/5 that has a denominator of 5, a 2/25 that has a denominator of 25, and a -5/16 that has a denominator of 16. What's going to be the LCD of those? Well, if I was just looking at the 4/5 and the 2/25, I would do a 25. But 25 and 16 have no common factors, so I'm going to have to use an LCD of 25 times 16. And I don't do that one very often, so I'm using my calculator to multiply those together. My LCD is going to be 400. Now, Ms. Chen, what if I accidentally choose the wrong least common denominator to multiply by? That's okay. You're going to figure that out. If it's not actually the least common denominator and it's a bigger number than you needed, it's going to simplify just fine. And if it's not a common denominator and you needed something different, you'll recognize that as soon as we multiply and be able to fix it. So I'm going to multiply every single one of these little fractions by the LCD 400. And I'm going to make 3 different problems and simplify them. So when I multiply 4/5 times 400, I multiply the 4 times the 400, and I get 1600. And I multiply the 5 times the denominator, which is just a 1, which gives me 5. And 1600 divided by 5 is 320. Now I'm going to do the same thing for the next problems. I get 800 divided by 25, and 800 divided by 25 is 32. And now finally I'm going to do negative 5 times 400, which is 2,000, negative 2,000, and 16 times 1, which is just 16. And negative 2,000 divided by 16 is negative 125. Now I feel pretty good about this being a least common denominator because I found numbers instead of fractions for each of these. Still, if I made a mistake, I'm going to find it pretty soon. And I can simplify, most likely to fix it. So I'm going to put all of these different numbers back into the formula or the expression where they came from. So I have 320 divided by 32 minus 125. And you guys already know that I can do 32 minus 125 and get negative 93. So that's going to be the simplest version of this fraction that I can get because neither of those two values has any like factors that I could simplify. Now in number 5 you'll see that we start working with variables. So find all your baby fractions. I have one here and one here. What's the LCD? It's an x. So I'm going to multiply all of the terms in this entire problem by x. This term times x, this term times x, and this term times x. Even though that wasn't a baby fraction, it gets multiplied. So let's look at those. So for x times x in purple, I get x squared. For x times 3 divided by x in green, I'm going to get 3x divided by x, which you probably remember simplifies to just a 3 because x divided by x is 1. And then finally, in orange, we have x times 1 over x, which is x divided by x, and x divided by x is just 1. So now I'm going to substitute these back into the original expression, and I have x squared divided by 3 plus 1, which can be simplified if I combine like terms to give me x squared divided by 4. There's no way to simplify that either. Now in number 8, the same idea applies here. The baby fractions are 4/5 and negative 4 divided by a, and my least common denominator for those baby fractions is going to be 5 times a. So I'm going to multiply all of these terms by 5 times a. This gets a 5 times a, this gets a 5 times a, and this gets a 5 times a. All of the terms, top and bottom. So let's write those little expressions and see what we end up with. Now you may be wondering, why am I multiplying times 5a on the right-hand side sometimes and times 5a on the left-hand side sometimes? Remember, it doesn't matter which order you multiply in because of the commutative property of multiplication. So you can multiply in any order you want to, as long as you get the correct thing when you multiply. For a squared times 5a, I get 5a cubed. For 5a times 4/5, multiply the numerators, 5a and 4, and I get 20a. And the denominators are 1 and 5. When I multiply 1 times 5, I get 5. And when I simplify, 20 divided by 5 is 4. So I get 4a for this one. In the next one, 5a times negative 4 is negative 20a. And in the denominators, I have a 1 and an a. So just an a. Remember, a divided by a is just 1. So I'm left with negative 20 here. Let's put these back into the original expression. So I have 5a cubed divided by 4a minus 20. Now I can factor this to get 5a cubed divided by 4 times a minus 5, 4 being the GCF in the denominator. But I don't have any factors that I can simplify in this problem. So really, I would be fine with you guys leaving this problem in either of these two ways. So you can pick between those two if you'd like to. In number 12, it starts looking a little scary, but we're going to follow the same procedure that we've been using. We're going to look at all the baby fractions, and this time we have 4 of them, and we are going to ask ourselves, what's the least common denominator? Well, this first baby fraction has a denominator of m minus 3. This second baby fraction has a denominator of m minus 4. That wasn't in the last one, so we're going to have to include that in our list. The third baby fraction has a denominator of m squared. That wasn't in our list either, so we have to include that. And the final baby fraction has a denominator of m minus 3. We already have that one, so thank goodness we don't have to add that into our least common denominator. So our LCD is going to be pretty intense. It's all 3 of these parts, and I have to multiply every single baby fraction by these. That's a lot of writing. It's not hard, but it's a lot to do. So instead of rewriting all of these as separate little problems, I'm going to work with them right where they are. I've got all of this times all of this. And when I multiply the tops together, I'm going to have every single thing that's on top of the fraction bar in either of my two things that I'm multiplying together. And the only thing on the bottom is going to be this little m minus 3. Do you notice that there's another m minus 3 that's on the top of this fraction bar right here? So those will simplify to give me a 1. And all that I'll have left for this fraction is the 16, the m minus 4, and the m squared. Now what about the next little fraction, which has a lot going on in it over here? If I multiply these together, I'm going to have the 4 times the m minus 3 times the m minus 4 times the m squared divided by this little m minus 4. And notice once again that the denominator has a matching factor in the numerator. And when I divide those, I get a 1. So here I'm going to have a negative 4 times an m minus 3 times an m squared. Now why did I say negative 4? Because this was a minus there. In the denominator, I'm going to do the same thing, and this time when I multiply all of this times 16, I'm going to be dividing it by m squared. Notice that there's an m squared in the numerator and the denominator. When I divide them, I get a 1. So in the numerator, or here I'm going to have a 16 times an m minus 3 times an m minus 4. And this is going to all be underneath the fraction bar, because here's the fraction bar, we kind of buried it, but this is dividing those two things. And finally, we have the last of our little baby fractions that we need to multiply. So we're going to multiply negative m minus 4, negative because it's minus, times all of this divided by this little m minus 3. And you see we have a matching m minus 3 up here. So we're going to have a minus m minus 4 times another m minus 4 times an m squared. So we had 2 m minus 4's up here. That's why I had to write them twice down here. Now in order to simplify this, I'm going to need to have a little bit more space. So I'm going to move all this up a little bit, and I'm going to simplify the numerator and the denominator of this one at a time by distributing and foiling or double distributing to simplify. So let's see what we get. So the first thing I did was I just rearranged the m squared and put it beside the 16 to get 16m squared, which next I'm going to distribute. And I did the same thing with the m squared here. I put it beside the minus 4, and now I'm going to distribute that. In the denominator, I multiplied the two binomials together to get m squared minus 7m plus 12. And then I multiply these two binomials together to get m squared minus 8m plus 16. And now I'm going to distribute what's outside of that. So this is what I get when I distribute. Remember in this first one, m squared times m is m cubed. And down here we have an m squared times m squared, which is m to the fourth. So be careful with your exponents. Remember to add them when you multiply. One thing you'll notice that I made a mistake on, when I distributed this negative right here, I should have multiplied the negative m squared times the negative 8m to get a positive 8m cubed. And I also should have multiplied these two to get a negative 16m squared. So watch out for those negative signs because they can trick anybody, even if you've been doing this for a really long time. So the last thing I need to do is combine some like terms. Alright, so I found some like terms with the same variables and exponents in the numerator and in the denominator. Did you guys notice that in the denominator I had a positive 16m squared and a negative 16m squared? And so those ended up being inverses of each other, so we don't have any m squareds in the denominator anymore. So this problem took a little extra effort than the other ones. But we found an answer that can't be simplified more than this because there's no GCFs and we can't factor this at all. Now for one more that's a little bit more challenging like the last one was. In this one we have four little fractions and we need to find the least common denominator for all four of them. Let's start with the numbers 6 and 9. The LCD for those is 18. And then we have the x minus 6 and the x minus 2. So all of that is going to be our LCD, and we need to multiply each of these terms in the numerator and denominator by that. Alright, now let's extend these fraction bars because when I multiply, I'm multiplying all the tops and dividing by all the bottoms. Notice that 18 divided by 6 is just a 3. So this is all I have left over for that one. In the next part, if I multiply all the tops and divide by everything on the bottom, notice that I have an x minus 6 here and an x minus 6 up here, which are going to divide or simplify to give me a 1. So have all this left there. And then if I multiply all of this top by this top as well, notice that I have the x minus 2 divided by the x minus 2, which divide to give me a 1. So I have all of this left. And one thing I can do right now is go ahead and multiply the 18 times 36 and get 648, which makes that look a little bit better, I guess. And then finally, if I multiply the 4 times the 18 times the x minus 6 times the x minus 2, notice that 18 divided by 9 gives me just a 2, so I get all of this. And we know that 4 times 2 is just 8. So now I need to simplify a lot. So here's one step where I distributed these to get this. I rearranged these two to get this. I distributed this to get this. And then multiplied these together to get this. Now that's one option for what you can do next. There's lots of other options. So we're going to keep simplifying until we don't see all these parentheses anymore. Alright, so in this one I multiplied these two together to get this. In this one I multiplied these two together to get this. In this one I did absolutely nothing because there was nothing to do. And in this one I multiplied these two together to get this. Now I've got just a couple more steps of simplifying to do. This time I combined all of the denominator to get my final answer for the denominator here. Yay, that's done. In the numerator, I multiplied the 3x times all three of these terms, and then I multiplied the negative 18 times all three of these terms to give me all of this in light green down here. And I also multiplied the negative 18 times all three of these terms to get the light purple. So now all I have to do is combine that numerator and I'll be done. Alright guys, we did it. Now technically we do have a GCF of 3 here and a GCF of 8 here. But we're going to call it a day on this one because even if we factored those out, we wouldn't be able to simplify 3 over 8. So we finished this problem. See what you can do with the rest of them.